I'm Tracy Gill, work in ADT, the Research and Technology Management Office, and one of the things I do is I support the X-Hab Academic Innovation Challenge. Academic Innovation Challenge allows us to work with universities across the country during an academic year on projects we put out that are of interest to us. So we're about to go into our 5th year of X-Hab, and this is actually the team from Colorado. This is their 2nd year. So what they're studying is robotic systems for to enhance plant production for plant growth for food production. This is Heather Hava and Daniel Zukowski from University of Colorado, and they're going to talk to you about Roger and Spot.
We're the main project managers for this semester. Daniel was the project manager last year for X-Hab, which you'll see a little bit about what we did, the heritage, where this came from, and where we're going. I'm Heather, and this is Daniel. Next slide. And we had quite a larger team, as you can imagine. The two of us didn't do this all on our own. Roger can drive around and do different tasks with the plant, care tasks, inspection tasks, pruning, harvesting tasks with the arm, picking Spot up, moving Spot around. So Spot is a smart pot, Spot, and the idea would be you'd have multiple spots, plus you can use unused space in little cubbies or small places that might not have been used for something else to get some more production out of the system. And then how would we address them, and what can we control, what can we not control, what were the most critical things. Next slide. So the Spot design, essentially what we have here is, as you can see, it's basically, this is the CAD of what we have sitting on the table. So when the robot comes up to the plant, you can get full access to the plant. Secondly, we need to make sure that we could circulate the air. So in a place like, I'm hoping to send these to Antarctica for my research, so I'm working on human-plant interaction research, which I'll talk a little bit more in a minute. Basically, you have an extremely dry climate, or like in Colorado, you have extremely dry climate. Plants don't like that, so you need to be able to get the humidity up. So we have an enclosure to regulate the air. Some of the other things is you have to have a water and nutrient basin, but you don't want the roots sitting in water all the time, so I'll talk more about how that works in a second. You have to be able to circulate that fluid and monitor all the different levels in that fluid. Area is limited. And that's pretty much it on that slide, so next slide please. Okay, so some of the things I mentioned. So the things we can control, which is a big question. Well, how do we control humidity? A passive humidity tray right here that has fresh water, and that just evaporates up. So when the humidity is too low, it's going to naturally evaporate and raise the humidity, which we're monitoring. So we can control humidity by opening and closing the chamber. We can turn the fans on and off, and we are going to add the ability to monitor CO2 and O2 so that when the CO2 gets too low, we can open the chamber and get more in for the plants. What are the different parameters? They can do that locally. They can also control all the functionality of Spot through this. You're going to see us control it through the interface. So this is remotely operated, so somebody on Earth can take care of the plants and reduce the workload for astronauts, and that's why we have Roger as well. We want to measure, and then it'll give us alerts. So you can see, it's a little hard to see, but you can see when things are going to be out of range, it's going to tell us that those things are out of range, and then eventually it'll tell us what to do about that as well, and the functions that it allows us to have with Spot. Next slide. All right, now to the good stuff. Roger, Daniel, take it away.
Okay, thanks a lot, Heather. I'm going to just do 2 minutes real quick, run through the capabilities of Roger, the remotely operated gardening robot. When we drive around, we can actually pump from that tank and refill Spot remotely. Roger's also got the robotic arm from last year. This was developed by the X-Hab team for round 1. We can use this camera to inspect up close the plant and assess the plant's health and see what else needs to be done. The forklift is designed to interface with Spot and pick these things up and move them around the habitat and utilize the unoccupied, unused habitat space and grow some edible food in those spaces. Roger's got 2 IP cameras on him. He's got the arm cam like I just described, and he's got this camera which is used for navigation. So we've got these Mecanum wheels, and if you come up after the presentation and take a look at them, they're pretty funky looking. If you've seen them before, you know what they are, but if you haven't, you're going to be like, how does this thing actually drive? Because all the wheels are actually tilted at a 45-degree angle, and these kind of wheels are great for making movement happen in a tight space like you'd have inside of a habitat. And there are wheels within wheels. So it's kind of a really nifty system, and we're going to drive it in a second.
Anything I want to point out? Okay. Bring up the interface. So Daniel's going to control. I'm going to sort of talk through a little bit of what we're seeing here. This is the camera that you're seeing right here that he's using to drive. And then this other camera that you're seeing right here is the arm camera. These interface controls for Roger, he's actually using a hand controller. These controls will be working, these controls will be working, and we have similar monitoring capability. Battery is gonna drive up, and we're gonna look at the small plants, and then we're gonna do some tasks with Spot. So right now you can see the light turning on and off. Do you have the red light on? We're opening the enclosure if it's hard for you to see right now. Daniel, if you open the enclosure the other direction, it should open a little bit further. One more time. Currently the arm has a gripper on it right now that's holding the camera. That end effector is going to be upgraded to do other pruning tasks. Lower it back down, drive it to a new location, set it back up on another table or on the floor. In order to have plants, you're adding a workload. So that's where this part comes in. So while we want to improve their nutrition and we want to have the access to nature, we still need to make sure that it's not a huge workload, it doesn't add additional stress. And have people operate them for about 9 months and have them do some surveys and understand what is the psychological benefit of having the fresh food and having access to nature in that very similar condition as Mars. How much do they like having the plants on board? How much time do they want to spend with them? Those kinds of things. And be able to correlate that to real space flight data.
Took a lot of that we learned from last year. We did surveys, user studies, and then applied some of that to this and came up with a much better interface this year than we had last year.
So we might be able to have it come and do, you could probably talk more about it. We did have rangefinders and things, and it was supposed to be able to drive. Vision is key, and that's some of the things we're working on with Dr. Carell's lab, is looking at doing point cloud, where they can come up, use the camera, turn the plant, scan it, get all the point clouds, and then create a 3D image of that plant. From Mars, you're not going to be able to do real time. And so then from that, we're going to use machine vision to identify fruits, flowers, stems, leaves, those kinds of things. Nice. That would be pretty awesome. Yeah, no, it's been fantastic. Last year we know like wires picked it up and with all the demos. So we're gonna after Wednesday we're gonna do the leak test and put water in and get a plant in there and running and hopefully actually get to grow it for even just a few days to get real data with the EC and pH and plant interaction. And he has a bunch of equipment that you can measure physiological responses to stress, like skin conductivity, I guess moisture. Then we still want to have the capability of being able to do it, but we may allow the astronauts to do it at will, and then we would want the system to adapt and then be able to know, oh, okay, well, it was already harvested by the astronauts today, I don't need to do that task. You know, having the salad with your stored food, with your MRE basically, you know. So that, you know, in terms of keeping them happy and like eating enough food, it's gonna be really important. Yeah, exactly. That's what. Well, last year we had the idea when we did the user test. We said we had, you know, a jalapeno and a tomato, but literally the great thing was with Hub, we had them come in. I explained them, and they had about 5 to 10 minutes to play with the interface and be able to look at Hub and see what the interface is. So just kind of click and try. Nice. That would be pretty awesome. Yeah, no, it's been fantastic. Last year we know like wires picked it up and.
I think it's gonna do.
Well, yeah, and I know like when they get thanks, Tracy. Yeah, you know, one of the things I know is when you get fresh foods everywhere, you have to move this tape frequent. It's like I heard they just like
show up.
Oh,
yeah, that'd be great.
If you want to, link
Yeah,
it,
that's what we want.
it goes on our website.
Okay.
You go to the.
Apparently, like the EPS team program a really cool, like animated intro on the
Down at the
LCD
bottom.
over there.
And so we would have one story in half. This is the story right now. We have about 1,175 words.
Oh wow. Okay. Yeah. Right. Yeah.
So we'll crack 1,200 on the story as possible by the time I finish it. But it'll be off the web, and then news media can see that.
It's all.
Nice. That would be pretty awesome. Yeah, no, I mean, it's been fantastic. A lot of, I mean, last year, we got a lot of interest. I mean, a lot of people that we talked to in the community are really interested in it and stuff. And they, you know, this is the first time we've ever ran a system together. Yeah. So that's what it's like. They finally have a show. Yeah, exactly. That's what, well, last year we had the idea of when we did the user test, we said we had, you know, a jalapeno and a tomato and but you know, it was literally, the great thing was, with Hub, we had them come in, I explained the functionality of Hub, what all the things it could do, but not how they were done.